relative to the absolute ether frame, came up with a figure of 378 kilometers per second towards the Leo-Aquarius axis, a line in that direction. And this checks perfectly with what they found by studying the anisotropy of the 3-degree Kelvin microwave background radiation. They come up with 377 kilometers per second towards the constellation of Leo. In my written work, I've mentioned Marinov. Marinov did some experiments on the trying to measure the speed of light, one-way speed of light, but I don't cite his work anymore. There's some doubt has been cast on his work, so I'd rather cite Silvertooth's. Okay, here's a picture of the reactions that are going on. I'm postulating, imagine we have several different kinds of etherons, and they're reacting according to this set of reactions. In other words, we have inputs A and B and output Z and omega. That's what makes this an open system. You have input and output. X, Y, and G are variables. They're allowed to vary, whereas these we hold constant. I'm suggesting that the physical world is made out of variations, waves of these three. And here's an example of what this might look like if you were to make a hydrodynamic example. You're starting here with A, that's etheron concentration. The concentration is represented by the height of the water level, and the flow out of this into G, the transmutation from A to G, it's sort of like a chemical reaction going on, is proportional both to the concentration, in other words the head of water, and the size of this orifice, which is determined by the kinetic constant K, and so on down the line. And you also have reverse reactions going on with reverse constants, and these are for all of these. I just haven't drawn them in. This is what it looks like if you do it formally. This is a chemical kinetic approach. Actually, I've taken a model already developed by Prigogine and his group called the Brussellator, and I've modified it. To get the Brussellator, you just take these two equations and you substitute A goes to X. Okay. But you need to put in the G to make it physically realistic. I won't go into that. Here are the equations you write that represent G, X, and Y as variables. And if you model these on a computer, theoretically you could produce subatomic particles that would attract each other, just like according to laws of electrostatics and gravitation. Here's what it looks like if you string these out according to the level of reactivity. In other words, you put the A and B higher, because it's sort of like the input levels, and the Z and omega lower, and there's also other states upstream and downstream. And here is the physical universe. So we define in effect what we call a transmutation dimension. This whole thing, all of these etherons transmuting, constitute together an ether, the transmuting ether. It's collective ether. Okay. Individually, if we represent the individual etherons by these letters, we find that they would react similar in this fashion. These are just two of the equations I showed previously, just schematically represented. In this physics, you get into the idea of critical thresholds. Wave behavior doesn't emerge initially. It's if the reaction system is what we call subcritical. Think of a nuclear reactor. I don't want to start off the alarm. Like in a nuclear reactor, it's subcritical. You remain with the uniform distribution of the ether in a subcritical state. However, if a certain part, imagine a certain part of this ether becomes supercritical, then fluctuations in the ether can become amplified and turn into particles. And this is what we call a bifurcation diagram. In that as you increase the criticality of the system, of the ether, you come to a point where suddenly the uniform steady state is unstable, and you have two possibilities now. This is where wave patterns emerge spontaneously now from the ether. And the two solutions represent a positive and negative particle, sort of like matter and antimatter. So that falls out of this naturally. This shows the sequence that goes on. Initially, this is the vacuum state, the beginning of creation before the emergence of matter and energy. By the way, you don't need a Big Bang theory in this cosmology. So imagine that the G and Y, we're not plotting X here just for simplicity. Imagine these ethers are uniformly distributed initially, and the space is initially subcritical. Then imagine that at a certain point you get a gravity fluctuation. The G represents gravity, and X and Y are representing the electrostatic field. Now these are potentials. In this physics, etheron concentration is identified with energy potential. So G would be equivalent to gravity potential, and X and Y electric potential. The reason you need both X and Y for electric potential has to do with the polarity. It's the nature of the system. You need the two X and Y. They behave to each other like yin and yang. In one polarity, X is high, Y is low, and the other, Y is high, X is low. This is the way. Without that, you couldn't get particles. And it's just a natural thing of the system. And this is not an ad hoc thing. This is pretty much very general. This is in a lot of fields. You know. Imagine now that you have gravity fluctuation. Now, in this theory, what regulates the criticality of the ether is gravity. Okay. Now, what you in fact do is produce a supercritical region, and if by chance an electric potential fluctuation, in other words fluctuation, let's say in Y, happens to arise at the same moment within the supercritical well, then you get amplification. Eventually it grows into a particle. But of course the particle has, in this case, let's say it's a proton, generates a gravity field. So it self-stabilizes itself. Sort of a bootstrapping. Now, here we get into the idea of zero-point energy. In physics, they talk about quantum vacuum fluctuations. Those are different from what I'm proposing here. In the quantum fluctuations, you have to have a whole quantum emerge at a time. I'm talking about subquantum fluctuations that might be a millionth of that. And they don't get to a quantum level to be able to nucleate a particle until they grow, and that only happens under supercritical conditions. The advantage of this is it's a lot more probability to have a very tiny fluctuation than it is to have a huge fluctuation. You know, maybe you do get quantum fluctuations, it allows it in this physics, but they are just extremely rare. You know. So this makes the creation of the universe extremely probable. Okay. If you were to look at what this particle would look like when it emerged, this is in 3 dimensions. If you were to do a computer simulation of it, it would look like this, sort of like concentric spheres. We're doing a cross-section of it. In this case, a core that's high in Y and low in X, and then a shell at high in X, low in Y, and it alternates like that, goes out. Now this has a certain specific wavelength. This is not ad hoc again. This drops out of the equations. If you were modeling on a computer, this is what you'd see. This is what you identify with the Compton wavelength. And here you have a very nice resolution of the wave-particle dualism. Okay? Because you have both a wave aspect and it's a particle. As you go towards the center, the field gets stronger. In fact, I show that if you scatter this from a diffraction gradient, it behaves just like what de Broglie found. This should have showed this earlier. This just shows a relation between concentration, etheron concentration, and energy potential. Here, this is equivalent to a vacuum, but as soon as you get a gradient in the potential, you have a possibility for force. So force emerges as a gradient of the energy potential, which is like it is in physics. The steeper the gradient, the greater the force. In subquantum kinetics, force is created by the potential stressing the subatomic particles structure. Okay, remember the subatomic particle is also a wave pattern in the ether, And when it's exposed to a gradient, it's in effect getting its patterns being stressed. And like in Le Chatelier's principle, a body will respond to relieve the stress. So its motion is in effect a action to adjust to that stress. And that's how you get motion and force. This is a little more detailed view of the particle. It shows that this is a positive charge, positive mass particle. Here's negative charge, negative mass. In the one case, the Y potential is positive, in another case, negative. And the gravity here goes down in the positive particle. That's a little, turns it around. You think positive should go up, but in this case, because gravity, the idea of gravitational attraction, we're talking about negative gravity potential. Whereas in the antiparticle, it would be greater. Now, one thing it indicates here is that there's a correlation between gravity and electrostatics, which fits with the Biefeld-Brown effect. Have people heard of this? Okay. So this is one beauty of this physics, is it naturally predicts the anti-gravity effect, and presently there's work has been done on this. Brown in 1958 got a saucer to levitate itself, and I know through contacts that there are black research programs in the U.S. Developing this. They have developed manned craft. They have flown them. Okay, so we're not talking about theory. This is something that has happened. And people are scratching their heads because it doesn't fit in with Einstein's theory of relativity. By the way, Silvertooth's experiment throws out the door not only special relativity, because if you have an absolute frame, you can't have special relativity. It also throws out the window general relativity. General relativity needs relative frames. So the beauty of this physics is it offers an alternative gravity theory to replace general relativity. And it's one that's consistent with the Biefeld-Brown effect. Not only do you have these potential differences, okay, this again is not postulated. This comes out of the equations that you get particles that naturally charge themselves, plus and minus. In addition, you have fluxes, ether fluxes. Like, in effect, the ether will be flowing into this well from the environment in the positive particle. And in the case of the Y etherons, they'll be flowing outward. And the reason for this is that gravity, the graviton, the geons I call them, are being consumed in this region faster than they are in the environment. And that just happens to be the way the equations are, that when it bifurcates, that's what happens. Whereas the Y-ons are produced in greater abundance here. And it's this property that produces the field. It's very interesting because here we have a model where the field and particle are one. They're continuous. So we have avoided the wave-particle dualism, which has plagued classical physics. Okay? The other thing is it avoids the infinite energy absurdity, which has plagued even modern physics. In the modern physics, the energy potential goes to infinity as you approach the center of the particle. As you see here, it goes to a finite value. Okay. If you were to visualize the particles, the fluxes, this shows what the fluxes would look like in the two charged particles.